Okay, so this is R.1, the first section of the review, and we're just going to cover today objectives 1 and 2. Okay? We're going to start with objective 1, which is the real numbers and their subsets. This is, honestly, this was from, you've done this in Algebra 1. This was chapter 1 to some extent of Algebra 2. We're going to cover some topics, and notation is going to be a little bit different than maybe what you're used to. And there's some notation that we haven't used before. Maybe you've used it if you took pre-calc. But if you didn't take pre-calc, some of this is going to be brand new to you. So, just some definitions. A set is a collection of items known as elements. The things inside of the set are known as elements. Just want to get us on the same page with terminology. Okay, so we can express sets in one of two ways, and you need to know both. Okay, those two ways that we express those sets are what are called the roster method, which is the one you're probably most used to, and then set builder method.
What's the name of this chapter?
Chapter R. Okay, this is section R.1, and we're going to cover it in 4 days. Okay, so so I'm going to give you an example that we're going to then write using the roster method and write using the set builder notation. All right, so here's the example that we're going to put in both formats. First off, we're talking about the set of all even numbers between 0 and 10. That's what we're going to express in set notation in both the roster method and set builder notation. Okay, so what are those numbers? When we say the set of all even numbers between 0 and 10, what numbers are we talking about?
2, 4, 6, 8, 10.
2, 4, 6, 8. Not included. We don't include 0, we don't include 10. Between. Okay, so the roster method, we just list them. Okay, so there's the roster method. That's what it would look like. 2, 4, 6, 8. Make sure that you have the braces. Set notation has to have braces. Okay, not parentheses, not brackets. They have to be braces. So if you want to type, if you don't like writing that little squiggly grouping symbol, you can always grab a keyboard and find the brace in there, and then you can type the numbers in if you want to do it that way. Or you can practice writing the little squiggly and get good at writing the braces. Okay, that's what the roster method looks like. Set builder notation is a little bit different. Okay, it looks like this, where there's a variable involved, and we state what variable we're talking about, and then we draw this little bar. And then what follows that are the numbers, or the sets, or the expression that goes with it. Okay, and then what I'm going to put up here next breaks all the pieces down. Okay, so if you want to take a picture of that, or you can write it all down, and then I'll go through and explain what each part talks about and why it's significant for set builder notation. If you are writing things in set builder notation, just understand that there's going to be the variable that you identify first, this little bar. So this is the set of all x's, such that, and then whatever the situation is. Okay. So set builder notation has to have the identifying variable, and then it has to have the bar separating the content. Okay. So that's the different types of set notations that we're going to see. Okay. Here's another symbol that maybe you don't know. All right. You've probably never seen this before. Okay. Has anybody seen it before? Yeah.
It's an E.
It is not an E. Yeah. It's kind of an E. You can think of it like it's an E. Yeah, a pitchfork. There you go. All right. What this means, and you're going to have to do this in your homework, okay? 5 is an element of. That's what this means, is an element of. So 5 is an element of this set. The set of elements 1 through 5 and 7.
I don't know how to draw that without making an E.
It's like a side U with a line in it.
Is there any way to
It's a
type
curvy.
that? Or it's a W.
I don't think there's a way to type that unless you have a special mathematical keyboard.
I just use.
Next symbol, what do you think that one means?
6 is
Not
not an element.
Not an element, not an element. So 6 is not an element. Well, duh, it's not an element. Look, 1, 3, 5, 7. But we're looking at the notation. What the reason why I included this in the lesson is just to see these symbols and what they mean. And in part of your homework, you're going to have to take some mathematical stuff and translate it to English, and English to math. Just getting used to the notation, getting used to the terminology. Okay. Now, if you want, I want to say this is on page 2. I think it's on page 2 of your book. But this is all the different real number subsets that we need to know. And most of them you know already. You definitely covered this in Algebra 1 and Algebra 2. The one big difference. In this book, they use this funky H to represent irrational numbers. Okay? In previous books that you may have seen, there wasn't a symbol for irrational numbers at all. We don't use I because we remember that I is the imaginary number. We don't like to get that confused. So let's just quickly go through what all these numbers and their symbols mean. Okay? All real numbers is this funky R, script R. If you guys had me for Algebra 2, you know we talked about the script R, and it looked like that. Okay, this book uses a little different notation for that R. Again, I think this is on page 2 of your book, so you can screenshot it from there. Natural numbers, this N. Natural numbers are counting numbers. Okay, we start with 1. You never count starting at 0. You count it, start 1, 2, 3 on up. Whole numbers include 0. So as we move our way down this list, the set of numbers gets bigger. Okay? Integers, we use a Z. And integers are negatives and positives. Again, still no fractions, no decimals, no fractions, no decimals, no fractions, no decimals. It's when we get to rational numbers, Q, that we start looking at fractions and decimals. Okay? There's a bunch of examples here. If you can write the number as a fraction, where P and Q are integers, and Q can't be equal to 0, then it's rational. Okay? Couple things to keep in mind. Any terminating decimal, meaning it ends, doesn't go on and on forever. Any decimal that ends is rational. Any decimal that goes on and on forever but repeats is also rational. So 0.3 repeating, 0.6 repeating. Okay, and there's some examples down here. Okay, those are rational. So if you have a decimal that ends, it's rational. If you have a decimal that repeats, it's rational. If you have a decimal that never ends and never repeats, then it is irrational. Anytime you have a square root of something that's not a perfect square, it's going to be irrational. Pi is irrational. You learned about E probably in Algebra 2. That is irrational. Okay. On the next page, I'm going to give you a diagram, and that kind of shows the relationship between all the different numbers. I want to say this is on page 4 maybe in your book, but if not, you want to take a picture of that just to see the relationship. Go ahead. So here's the relationship. This big rectangle is all the real numbers. Okay. The real numbers are split up into irrational numbers and rational. Rational consists of integers, whole numbers, and natural. The entire set of natural numbers is contained inside the set of whole numbers. Whole numbers is natural numbers, including 0, 2. Okay, integers is all the whole numbers and then also negatives. And rational numbers are everything else that's not irrational. Okay? Let's talk about Objective 2. Objective 2 is about interval notation mostly. There's 2 differences in this section, this part, that you're probably not used to seeing. One is how we graph inequalities. We graph them a little bit differently here. And then interval notation. We've talked a little bit about interval notation when we were looking at distributions in statistics. When we had to come up with the lower bound and the upper bound, that's what we're talking about with intervals, okay? And we just want to make sure we have the notation right. I believe this is the slide that's got a huge... So on this page, eventually I'm going to fill the entire page with a diagram, okay? So don't feel like you need to take a picture at the beginning. I will let you know, all right, now take a picture, all right? And that way we've covered all of it piece by piece, and we'll kind of go from there. Here's the first example, okay? We've got set builder notation on the left. We've got a verbal interpretation, so what it means, and then the graph. And then we have interval notation. So in all likelihood, this notation is new. Normally, when we used to do this, we did an open circle and a closed circle. In this section, in this book, we don't do that. We're going to use a parenthesis or a bracket. Interval notation means, okay, so in this case, this is x is greater than a, which means a is not included, it's bigger than a. And so the way that we signify that is we signify it using a parenthesis. Okay, so greater than a means a or bigger, and it keeps going on and on forever. So a to infinity. And if you think back to what we did in statistics, we spent a lot of time with the upper bounds and lower bounds of infinity and negative infinity. It's the same idea. Since infinity never ends, you can always find a bigger number. We also put a parenthesis because it's never locked into a specific value. It's always just bigger and bigger and bigger, and it goes on and on forever. Okay, so this is what you're probably most used to. This means x is greater than a. So whatever the value of a is, instead of putting an open circle like we have, we put the parenthesis, and greater than is to the right.
Oh, it's a parenthesis?
That is a little parenthesis.
It's not open?
No. Well, in this book, they use a parenthesis and not instead of an open circle. Okay, so that notation is a little bit different. Okay, now here's where it changes. If it's greater than or equal to, meaning a is included, instead of putting a closed circle, we put a bracket. And so notice how the interval notation changes. The bracket goes near the a, meaning a counts. It's part of it. But then up to infinity, again, it's a parenthesis to say it goes on and on forever, and you can never find the exact value, right? If I flip it and go less than or equal to, okay, and that's what this is here, so less than b. So notice now I have negative infinity, and since b is not included, I use a parenthesis. Just wait till the end, Kalani, wait till the end. Okay. So notice again, I have the parenthesis at b, and I go to the left because it's negative infinity. In this case, the fourth one down, less than or equal to, b is included, so now I put the bracket instead of the parenthesis. Same looking thing. When I'm in between a and b, when they both don't have the or equal to, they both have the parenthesis with them because a is not included, b is not included, and I enclose them with the parenthesis to indicate that a and b are actually not part of that set. All right. You can have a mix where you have an or equal to, meaning a is a part of it, and that's where the bracket comes in, and the bracket coincides with the a, but b is still not included because it's less than b. So then I have the parenthesis. Okay. And then you could have both included, so now they're both brackets. Okay, and then the last thing to use for set notation is if x is the set of all real numbers. Okay, then notice here I go from negative infinity to positive infinity, and it includes the whole number line. Now if you want to take a picture, you can get all of that in your notes at one time. Here's the first example, okay, and obviously it has 6 parts. All we're doing, we have this set B. Okay, the set B contains all of these different numbers. Negative 11 sevenths, square root of 59, 4.3, 0, 23, negative 13, pi, and 4.9 repeating, which for all intents and purposes is 5. I hope you guys know that. And I could prove that to you one day if you'd like.
Do it right now.
No, we're not going to do it right now. What you're supposed to do here is pick out the elements of this set that belong to the set of natural numbers, the set of whole numbers, the set of integers, the set of rational numbers, the set of irrational numbers, and the set of real numbers. Okay, I can tell you. Let's be really clear right off the bat. There are no imaginary numbers here, all of these numbers belong to the set of real numbers, okay? And then you're gonna pare it down from there, so go ahead and do those real quick, and just knock it out. Which ones are natural numbers?
23.
23, anything besides 23 a natural number?
No.
No, 20.
I go.
Okay, 23 is an element of, and when you do your homework, you don't have to necessarily write it this way, but just, I'm going to use some of that stuff that we went over. Which ones are whole numbers?
0 and 20.
Right, so now I add 0 to the group, okay? For integers, what do I add to the group?
Negative
0,
13.
23.
Negative 13. So these three right here. Now for rational, anything that's a fraction, anything that's a decimal that doesn't end, anything that's a decimal that repeats, okay? So I'm going to add to that negative 11 sevenths. That's not a perfect square. I'm going to add 4.3. That doesn't end, and that's repeating. Okay, so those will be there. The only ones that will not be there or irrational, the only ones that will be in there are the square root of 59 and pi. Okay, and then the real numbers are all of them. Okay, so that's one example of the stuff that you're going to be doing in your homework today. One more example to go through, and this is all for objective 1. Now we'll go over an example for objective 2. Okay. This go ahead and take a picture of because you're going to fill in the blanks. So we're comparing the graph to interval notation to set builder notation. Where I feel like you're going to want to you're going to kind of want to make your home at set builder notation because you're already familiar with that. And so that's where I would start off everything. Obviously in the first line and the second line, you can't do that, right? So but what I'm saying is when you're given the graph, when you're given interval notation, go to that set builder notation, and then it'll probably be easiest to then work off of that. In fact, maybe it's easiest to do the last line first. I don't know. But go ahead and fill in those blanks and see what you end up with, and then we'll come back and see if you did it right. So, since it's a bracket, that means 2 is included. So this is and since it's going to the left, this is a less than or equal to situation. And it goes on and on forever. So for the set builder notation there, we've got the brace and then the x with the bar. So x is less than or equal to 2 because of a bracket. All right. And then when I do the interval notation, I know that the right side is going to be a bracket and the left side is negative infinity, which makes it a parenthesis. So it should look like that. Question?
I didn't get any of that.
Okay.
It's from December 5th.
Yep.
I didn't.
Okay. Now, for the second one, since it's a parenthesis, it's not going to have the or equal to. And since I'm going up to positive infinity, it's greater than. Okay. So for the set builder notation, you have x greater than 7/2, which is what we need to know what 7/2 is to put it on a number line. 3.5, 3.5, yeah. So my graph is going to basically, I'm going to have a parenthesis at 3.5, and it's going to go up. It's going to look like that.
I don't like set builder notation.
I understand.
It's a lot.
And then on this last one, I have a or equal to and a not or equal to. So I'm going to have a bracket with -4 and a parenthesis at 2.3. Okay, and then I'm going to just put that on a number line. So that's our final result.